Okay, hi everyone. So if you're new to this, the idea is that we're going to produce a vodcast every time we do a test, and the idea is that if you don't understand any of the questions, you can check out the vodcast and hopefully gain a better understanding of the things you weren't able to comprehend whilst doing the test. What you'll find is that the questions go in the same order as they were in the test, so we'll be doing the tech-free section first, followed by the tech-able, and of course if you need to skip forward at any point, you're more than welcome to do that. Okay, so let's begin. Now, we thought we'd give you a really easy question to start off with, and how wrong we were. Turns out you guys are just hopeless when it comes to expanding brackets. So let's look and see what would happen with the first thing. With the 5 there, well, there's nothing happening with the 5 because it's not connected with the bracket, so it just stays as 5. But meanwhile, when we come to expand, we count this as being negative 7 times 6, which gives us negative 42, negative 7 times negative y, and that's equal to plus 7y, and the whole thing is equal to negative 65. Well, from there, it's just a matter of simplifying. The hard part is getting this correct in the first part. If you've got it correct, then you'd find that everything else dropped out quite nicely there, and you've ended up with an answer of y is equal to negative 4. Let's look at the second part. In the second part, we notice that the negative 7 is on its own, so it can be taken across to the other side by adding the 7 to both sides. That leaves us with the negative 8 minus x over 2 equals negative 8. Now, because we've got two terms, we've got a minus on each side, we could actually choose to just cancel those out, in which case we would have had 8 minus x over 2 equals 8. From there, you could have done 8 minus x is equal to 16, minus x is equal to 16 take away 8, which is 8, and then x equals negative 8. However, the very observant people amongst you would notice that we didn't quite do it that way. So let's just rub this out and start again. And what actually happened here was that in the first line, we've multiplied by positive 2. This left us with negative outside of 8 minus x is equal to negative 16. Now, it's important that we understand that the negative is operating on the 8 and the minus x here. So when we expand our brackets, we get negative 8 plus x is equal to negative 16. From there, we can see that eventually when we add the 8 to both sides, we're going to get x is equal to, well, it's just negative 8, isn't it? And so we get our answer. Okay, so this question was just a fairly straightforward application of the distance formula. So remember our distance formula, which is based on Pythagoras, says we have y2 minus y1 squared plus x2 minus x1 squared. Now, with the y2, that's the y from the second bracket, so that's going to be square root of 7 minus negative 5. Now, 7 minus negative 5 is going to become the plus 5 that you see up there. That's all squared, plus negative 3 minus 6 all squared. From there, we just realise that that's going to be equal to 12 squared, 144. That's going to be negative 9 squared. That becomes plus 81. And then that equals root 225. What you're meant to realise is that root 25 is equal to 15. And of course, if you didn't do that, then you can't expect to get full marks there. So we've got a set of simultaneous equations here, fairly simple really. What we need to do is to use the elimination method, so we're going to multiply equation 1 by 3. What this is really about is how to set things out. So the first equation we've labelled with a 1, second one with a 2. We've told the person who's reading it what we're doing. In fact, we've multiplied it by 3. So 2 times 3 is equal to 6x, y times 3 is 3y, 6 times 3 is 18. Notice we're putting a 1 with a dash there to indicate that the equation has been derived from equation 1. Here we're just writing equation 2 as it stood. Now that we've got that, we're telling the reader what's happening, so we're doing equation 2 minus equation 1. This gives us x is equal to 1.5. Now, in order to find out what the corresponding y value is, we tell the reader we're about to substitute that into equation 1. So we do sub it into equation 1. Now equation 1 said 2x, so 2 times 1.5 is 3, plus the y is equal to 6. Now it's just a matter of minusing 3 from both sides, and we get our answer y is equal to 3. And there you have it. As you can see from my notes here, I've said there's a couple of methods that are available here, so I'm just choosing one that you could have chosen. And essentially what I'm saying is that if we know that we've got the points A, B and C, if we find out the gradient between A and B, and if we find out the gradient between B and C, and if we notice that the gradient is the same between A and B as it is between B and C, well, it must form a straight line because you've got that B being a common point. So that's exactly what we're going to do. We're going to find the gradient between A and B. Now remember our rule for the gradient, m is equal to y2 minus y1 over x2 minus x1. And that's what we've done here. So we've done 8.5 minus 6, because that's 8.5 minus 6 there, all over 2 minus 1, and that's just equal to 1 down here. Well, we notice that that's equal to 2.5. We're very happy with ourselves, but unless the gradient between B and C is the same, we can't be too happy. Well, as it turns out, we can be happy, because now what we do, I'll just rub this out. Now we do 13.5 minus 8.5, which is happening here, over 4 minus 2, which is happening here. Well, that turns out to be equal to 5 over 2, and 5 over 2, as you'll know, breaks down to being equal to 2.5. Now we can say the gradients are the same, and because they're sharing the same point, that means they must be on the same line, and so yes, they are on the same straight line. Okay, there's a couple of methods available in this one as well. One that I'll just mention over here quickly is if the points are in a right angle triangle, and let's just draw a quick diagram so we can see what's actually happening. Point 5, 10, here's 5, here's 10 would be about there, wouldn't it? 2, 1, that's probably going to be about there. And the last one, 5, 0, is going to be about there. If we join these points together, where would the right angle be? Well, it looks like the right angle would be here. So if it's a right angle triangle, that means the theorem of Pythagoras will hold. In other words, if we let that be A, that be B, and that be C, we would say if A squared plus B squared equals C squared, then we've got a right angle triangle. But that's not what the method is that I've used here. What I've done is I've said if two lines are perpendicular to each other, then you're going to find that when you multiply the gradients, you'll get -1. So let's have a look and see what the gradient is between A and B. Using our same rule as before, the gradient between A and B is 3. The gradient between A and C, well, this represents a bit of a problem, because we've got 0 minus 10, that bit's okay, but on the denominator we've got 5 minus 5. This is undefined because it means you're dividing by 0. Now we can't have that, so we cross our fingers and hope that something else good is going to happen. As it turns out, when we work out the gradient between B and C, we get -1/3. Now, -1/3 multiplied by 3 is equal to -1. So that when you multiply these two gradients together, you get -1. Whenever you multiply two gradients together and you get -1, this means that the lines are perpendicular to each other. By the way, that little upside down T sign means AB is perpendicular to BC. Now, once we've shown that there is a right angle in there, there's 3 points. When they join together, they must form a triangle because one of the angles is a right angle. It must be a rat. What's a rat? A right angle triangle. Okay, so in this question we're talking about families of lines. So the particular family that we're talking about here is the lines y equals mx minus 5. Now we understand that that's going to be a straight line because it's in the form y equals mx plus c. The difference being that we already know what the c is equal to, so we've got y equals mx minus 5. Now the first question says we've got to find the x-intercept. To do that, we just let the y equal 0. This means that becomes 0 equals mx minus 5. that's what this line here is saying. From here, it's just a matter of rearranging until we've got the x on its own, and that's what we get there. So x is equal to 5 over m. No worries about any restrictions here, because here we're told that m was a positive number. Okay, in part B, it says for what values of m is the x-intercept less than 6? Well, here's our expression for the x-intercept. It's less than 6. So now what it's a matter of doing is rearranging. Now, if we rearrange, we can multiply both sides by m, so that gives us 5 is less than 6m. Then we can divide by 6, so 5 on 6 is less than m. You've got to be a little bit careful when you do this step, because what we did here was we multiplied by m. If m had been a negative number, that would have meant we'd had to reverse the inequality. But remember, m is a positive number, so in this particular case, we do not reverse the inequality, we leave it in the same direction. So do remember, however, because the big teeth, the mouth is kind of facing the m here, if we're going to write it like this, the big mouth is eating up the m, so it has to go over there. Other way to think of it is, it's pointing towards the number. Here, it's pointing towards the number. Okay, so let's look at part C. It says find the value of m if the line passes through the point 5, 10. So remember that what we know is that it's a line of the form y is equal to mx minus 5. Our task is to substitute in 10. Instead of y, we put 10. M times, instead of x, we put 5 minus 5. Now it's a matter of transposing. Add the 5 to both sides, gives us 15 equals 5m. Now we just divide both sides by 5, and we get m is equal to 3. And now we have the dreaded parameter question. You knew it was coming, and here it was. So you're told that the equations had an infinite number of solutions. Well, we kind of know that anyway, so let's just go and have a look at see what's happening with the equations. If we take this one and we multiply it by 3, what we end up with is exactly the same as that. So they're really representing the same line. If that's the case, what you'd find is that they would be joined together or be sitting over the top of each other. So let's draw a quick sketch. So here we see x is equal to 12, so intercept there would be 12. Here we see 5y equals 12, so y is equal to 12 on 5. Joining together, we get that line there. Now what would happen is, if we were to draw a sketch of this one, 3x is equal to 36, x equals 12. 15y equals 36, that would simplify down to this 12 on 5, so the lines would be sitting over the top of each other. So we do have an infinite number of solutions. But that wasn't what the question was asking. It just said, if we let x equal lambda, how do we find out what y is equal to? Well, what we do is we choose one of the equations. It's the easiest one I'm going to choose, so x plus 5y is equal to 12. We were told to let x equal lambda, so that's what we do. We make that lambda plus 5y is equal to 12. We had to find what the y value is equal to, so now we need to rearrange. 5y is equal to 12 minus lambda, and then y is equal to 12 minus lambda all over 5. And there we get our answer. Now, of course, we could have expressed it like that if we'd wanted to, but I'm wondering if some of you would think, what if I'd chosen to use the other equation? Let's have a look and see what would happen. 3x plus 15y is equal to 36. Well, remember we said we're making the x equal to lambda, so we've got 3 lambda plus 15y equals 36. Transposing, 15y is equal to 36 minus 3 lambda, and then, that's right, okay. Now we're going to divide by 15, so y is equal to 36 minus 3 lambda, all divided by 15. Doesn't look the same as this one, but there's a common factor of 3. So if you divide this by 3, this by 3, this by 3, you do get exactly the same answer. So it works with both equations, which is good news. And so here we are in our little tech able section where we're allowed to use our calculators. So with the first one, It says you've got to find correct at 2 decimal places, and by the way, I did see someone circle this, and then down here write the answer is 71.6 degrees. Goodness gracious me, I don't know why you bothered circling it or underlining it, because what was the point? I don't know. Anyway, let's keep moving though. So we had to find the magnitude of the angle made with the positive direction of the x-axis. By the way, that's important. So with the first one, we've got y is equal to 3x plus 8. If we were to draw a quick sketch of that, it would look something like this, going through 8 there. And what we need to do is to try and find out what the angle is in here. So when it says the angle made with the positive direction of the x-axis, that's the angle we need to try and work out. Fortunately, we know that tan theta is equal to m. So that if we ever want to find out what the angle is equal to, we do theta is equal to inverse tan of m, and that's exactly what we do. Here we know the gradient has to be 3, so do inverse tan of 3, throw it in the calculator, make sure you're in degrees mode, and you get the answer 71.57 degrees. You can't go wrong. Well, you can go wrong, because in part B there's a little trick awaiting you. And what happens is, if you put the negative 4 in there, you're going to get a negative answer here. But what's that look like? Let's draw a sketch and see what's happening here. So negative 4x minus 8 would have looked like this, passing through negative 8 there. The angle that you've just found out is this angle in here. That's at negative 71, or negative 75.96. That's that angle there. That's a negative angle. We want the angle in here. So how do we find it out? Well, you can see here we just do 180 minus that 75.96, and we get the final answer 104.04 degrees. By the way, why is it 180? Because what we got here is a straight angle. And if we already know this one in here, to find this one, we do 180 minus whatever that one was equal to. So this question here is all about setting out as well. So we're going off to Macca's, and we saw that 2 hash browns and 1 Big Mac cost $6. Now, a common error here was people just launched straight into the equations without writing down what the X and the Y stood for, or some people use H's and B's. Altogether, we're using letters that we weren't really familiar with. So the key message here is, if you're going to introduce a variable, you must define it right at the start. So the X is the cost of the hash brown, the Y is the cost of the Big Mac. So from the question, we are told 2 hash browns and 1 Big Mac cost $6. That's where equation 1 comes from. We're also told that another customer, who apparently was very hungry, wanted 7 hash browns and 3 Big Macs. Well, that's a nice little snack, isn't it? So 7 hash browns plus 3 Big Macs, what does that cost? $19.50. Now, what you're meant to do, because it's a tech-able test, tech-able, is to use your CAS. That's the whole idea, guys. Use your CAS. So now you are allowed to say, I'm solving this on my CAS. When you do, you get the answers x equals 1.5 and 3. But that's still not enough, because the question specifically asks for the cost. So you must answer as the hash brown costs $1.50 and the Big Mac costs $3. Has to be in words. Worded question, worded answer. Make sure you answer the specific question. Use correct units at all times. Okay, even though this is fairly new, it was a pretty standard question for this type of question. So we had to find a value of m for which there would be an infinite number of solutions. Now remember, we've seen already, if there's an infinite number of solutions, the gradients will be the same, and because it's the same line, you're going to find the y-intercepts will be the same. So the whole method here is about putting these in the form y equals mx plus c, and then comparing the m's and the c's. So in the first part here, we're taking equation 1 and we're rearranging. So the first thing we do is to minus the 6x from both sides, then we're dividing by the m. So now we do have this one in the form y equals mx plus c. We can see the m is the coefficient of the x there, it's negative 6 on m. We can see the y-intercept is going to be 16 over m. Let's look at the second equation. With the second equation, we want to get the y on its own, so make 6y equals 6m minus all that bracket there, the m plus 5. Now what do? We divide both sides by 6, so y is equal to, well, 6m over 6 is just m. This is going to be negative m plus 5 all over 6. Okay, things are going along pretty well at this particular point because what we've got is everything in the form y equals mx plus c. So we see that if we've got infinite solutions, the gradients must be the same. So if the gradients are the same, we compare the two gradients. Let's just rub this out for a minute. So the gradient for this one was negative 6 over m. The gradient for this one was negative m plus 5 over 6. So they must be equal to each other. Now what it's a matter of doing is solving this. We're going to get rid of the minuses. We're going to multiply both sides. Do a little cross multiply there. So we get 36 equals m squared plus 5m. We've noticed that that's got the m squared in it, so we're going to realize that it's a quadratic equation, so we're going to make the whole thing equal to 0, and we're going to factorize it. We do factorize it, and from here we get m is equal to negative 9, or m is equal to 4. But that's not the end of the story. Let's rub that out again, and let's start again. So now we still need to compare what the y-intercepts are equal to. So the y-intercept for this one was 16 over m, the y-intercept for this one was m. So we've got m is equal to 16 over m. Now we just multiply both sides by m, and we get m squared is equal to 16. Remember, however, that if you've got m squared equals 16 and you take the square root, you must take into account the plus and minus answer. Must take into account the plus and minus answer. So what we've got is possible values are of m equals negative 9 or 4, and m is equal to negative 4 or 4. That's from up here. Well, we need to have the one which is common to both. That's this one here. So now we can write m is equal to 4. But take into account you must include the plus and minus there, and you must show all the other working in order to get your full marks. Okay, so question 4 turned out to be a pretty tricky one, so let's go through this fairly slowly and let's see what happens. So first thing I would do is draw myself a diagram showing me what's happening. So we're going from town A to town B, and on the way this way we're travelling at x kilometres per hour, and then we travel from town B back to town A, and now we're travelling at 2y kilometres per hour. The question asks us to find the average speed. So in order to find the average speed, we use this rule here. Average speed is equal to total distance divided by total time. Now we were told somewhere, where was it? The distance between town A and town B was d kilometres. So that means when you go in that direction, you travel d kilometres. But when you go in that direction to go back, you travel another d kilometres. This means that your total distance is going to be 2d. Now, in order to get an expression for the total time, we're going to go across here. I'm just going to rub it out for a minute. So here's what we know. We know that velocity or speed is equal to distance over time. If we transpose this, just swapping over the v and the t there, t is equal to distance over velocity. Why would we do that? Because remember, what we're trying to do now is to find an expression for the total time. So the total time is made up of the two components. One, where you're travelling in this direction, and the other when you're travelling back in this direction. So let's see what happens. The total time is equal to that, but we do notice that there's a common factor of d, so we take that out. So we've got d outside of 1 on x plus 1 on 2y. Now we go back to where we had our average speed. We'd already established that the total distance was 2d. Now we know that the total time was at d times 1 on x plus 1 on 2y. Well, guess what? There's a common factor of d here that can be cancelled out. That's actually good news. Here we're going to need to put everything over the same denominator. So we've got 2 over. If we put this over the same denominator, that means we're going to have x times 2y in the denominator. In order to get that on the top, we need to multiply that one by 2y, plus here we need to multiply that one by x. If we simplify that, it's 2 over 2y plus x all over 2xy. That takes us to where we're here. In the meantime, we realise that that's the same as 2 divided by 2y plus x all over 2xy. We use the stay, change, flip idea. That means it's 2 times 2xy over 2y plus x, and that is why we've got 4, because you do 2 times 2, which is our 4xy, and in the denominator you've just got the 2y plus x. So I'd rate that as a pretty difficult question, but certainly one which you're going to need to work on and find out a method which suits you so that you'll be able to get the correct answer in the future. Okay, I've got a funny feeling that's it. So good luck to you if you got this far, and congratulations for paying attention, and good luck very much to you for your next test. Okay, bye for now.